of number 30. 30 is an even number, so then I know it's divisible by 2. I always start with the smallest prime numbers. The smallest prime number is 2. And then I have 15. Now the next, obviously this is not an even number, so I cannot continue with 2. I have to move on to the next prime number, which is 3. And it happens that 5 plus 1 is 6, so this number is divisible by 3. So then 3 times 5 is, so this is the prime factorization of 30, which is 2 times 3 times 5. And that is it. That's all I need to do for the prime factorization, to find the prime factorization of a number. I have to think in terms of division, basically divisibility. So I start with 2, then I continue with 3, then I continue with 5, and so on and so forth.
Is there any other way besides a factor tree?
Yeah, I'm sure there are other ways. I think that this is very clear and visual, but if you want to use a different method, it's always acceptable.
I think how I kept messing up, like for that one specifically, I would have said 10 instead of 2.
But 10 is not a prime number.
Right, and that's what Matthew explained in the chat. He said that 2 times 5. So you would
No, you have to. We have to go step by step, starting with 2. If it's applicable, continue with 3. If it's applicable, we have to use prime numbers.
Okay, that makes sense.
Otherwise, we will go back and forth with, and so on and so forth. Now, you can also, if you want, you can write 30 as 3 and 10, and then write 2 and 5. Yeah, that's fine too. But then you have to write them in the correct order anyway. That's fine. It's acceptable. That is acceptable too. Good. Other questions? Anything else? So we started 1.4 basically with identifying variables, constants, and expressions, and how to evaluate algebraic expressions, how to identify terms, coefficients, and like terms. Okay, so I think we are ready to look at 1.4 practice. If you find anything that you would like us to look at, we will start with, okay, I see there's something in the chat. Do I have to answer to anything?
No.
Okay. Then if I don't have to, then I'll share my screen. And let's start to see more examples, more work. Okay. So we evaluated in certain situations. These are very simple situations. I showed you an example. Please look carefully and say, let's do this one, let's do that one. We did not select problems. I just gave you examples. But now we can select. Evaluate the following algebraic expression 4. I'll come back. You choose. If you don't choose, I will. So the first 4 are about evaluating. Then the next are about something else. So let's look. This we did, not in this format, but we did this together, but we can do it again. 1, 2, 3, 4. If you open your own assignment and you find a different problem that you want us to work on, please, let's choose. If not, we'll move on. Okay. So when we're asked to identify terms, 7z squared plus 9z minus 8, can anyone tell us how many terms we see?
3.
Perfect. Can anyone identify the leading term. I did not mention what the leading term is. So I'm going to change z into x because of the z that my handwriting is not very good on z. So I see here three terms. Are they in descending order? Yes, they are in descending order of the powers of the variable as we discussed. Power 2, power 1, no power. This one has an x, but because it has power 0, there is nothing there because a number raised to 0 is 1, as long as x is not 0. So this is the first term, this is the second term, this is the third term. Meaning, this, remember, terms, the sign in front of the term is part of the term. So this is the first term, second, third. They are in descending order. This is called the leading term. And this is how we determine the degree of the polynomial. The degree of the polynomial is the largest power, if it's only one variable, the largest power of the variable. So degree 2. The leading term also has a coefficient. Leading coefficient. This is the important terminology for what follows next. Leading term, 7x squared. 7x squared. Leading coefficient is 7. Degree of this polynomial, degree 2. The highest power of the variable. Any questions?
Yes. What if there's two variables? Like
Yes.
X and Y.
Yes. So if I have 7x squared y squared z to the third, let's say plus 7x, this has degree 1, but this has degree 2 plus 2 plus 3. So if in one term we have more than one variable, we have to add the powers of those variables to determine the degree. And what will be the degree of the whole thing? The degree of the whole thing will be the highest degree.
What if it was x squared or 7x squared plus 8y squared?
Still degree 7 because 7 is the highest degree. Oh, not here, you mean.
Yeah.
A different one.
Different one.
Oh, sorry. Yeah, sorry. Let me write it.
Okay. 7x squared plus 7y squared.
Degree 2. The degree of this term is 2. The degree of this term is 2. We are not adding degrees of terms. The largest is the degree of the whole thing. I didn't say 2 plus 1. No.
I meant leading coefficient. Like which one would be leading?
Normally we consider x first and y second, but you can say, wait a minute, my y is the important variable, then that will be your leading term.
Okay.
It depends on what importance you give to each variable. And normally we have x, y, z, but you may say, no, this is what I'm interested in, so this is the most powerful. Perfect. Very good.
Pick?
Say it again.
So you can pick which one?
It depends on how you want to label them. So if x is more important to you, then you will keep x as the leading term. If y is more important to you, then you will pick y. But normally in xy, we have x the first one. Is that okay? We looked at this one for like terms. Let's see if we need more examples on combining like terms. Do we need more examples on combining like terms? Find the like terms in the expression. Anyone? Are we okay with like terms? 3y lowercase and plus 8y uppercase. Are they like terms? Yes or no?
No.
No, of course not. The lowercase y is not the same with the uppercase y. Perfect. They're not like terms. Okay. Do we need to use a distributive law?
Yes.
Okay, perfect. So let's see if there is just one more interesting than 12. If not, we'll come back to 12. Okay, so we have 12, 13, because they have many. We have 12, 13, 14, 15. Yes, so we have 12, 13, 14. Okay, let's choose 12, 13. I'm sorry?
13.
13, very good. So in 13, they're asking us to use a distributive law, which we know. So this is 9m to the fourth plus 8m, which this is not the way we write it. We don't put a constant at the end. This is the same thing with 3, as we know, multiplication is commutative. 9m to the fourth plus 8m. It's not a mistake. But I have to distribute either this way or this way. The answer will be the same. 9m to the fourth times 3 is 27m to the fourth plus 3 times 8 is 24m. Are these like terms? Can I further simplify this? No, of course not. 2 terms? Can anyone give us the degree of this polynomial?
5.
We do not add if they do not belong to the same term.
4.
4. So the degree of the entire polynomial is degree 4. This is the leading term. Can anyone give us the leading coefficient of this polynomial? The leading coefficient? How much?
27.
27 is the leading coefficient. 27m to the fourth is the leading term because it's the most powerful. Is the one that transfers its degree over the entire quantity. Very good, awesome. Good. Good. We know how to use the distributive law. Simplify the following expression by combining like terms. 18 apples minus 21 apples. Can anyone give us the answer? 18 apples minus 21 apples.
Negative 3y.
Negative 3y. Very good. Any questions? Can we move on? Remember, this is not a monologue. Simplify by combining like terms. Can anyone give us, let's just work on this one for a moment. 7b plus 6 minus 3b minus 2. Can anyone tell us where to start? Anything? Anybody?
Combine the b like terms.
Yes. 7b minus 3b. What will that be?
4b.
That's it. And 6 minus 2?
Just 2. Or 4.
That's it. Done. Do not let me move on if you have any doubts or any questions, please. We're doing this.
Like term?
Say it again.
Can you group like terms just to make it simple?
Like,
Simpler?
how will I write it simpler?
I mean, if you had like a, if you had like a long equation, and there was like a lot of like terms, if you can group them together.
Only if they are like terms, yes.
Yeah.
These two are not like terms. 4 apples plus the digit 4 cannot be combined. This is it. Good. Everyone understands combining like terms. Okay. Can anyone quickly work on this and tell us the answer? 3a squared plus 4a minus 4a squared plus 5.
Negative a squared.
Negative a
plus
plus 4a plus 5. Very good.
Matthew, how do you do that so fast? I have to write it down.
Good.
I did this in high school, so I don't know. I was good at it then too.
Okay. 20. Do we feel like doing or working on any missing value like this? Okay. The distributive property or law? Yes, no?
Yes.
Okay, very good. So let's work on this. Negative 3 quantity, x plus 2 plus 8. After this, the homework should take you 5 minutes because we're going through everything. Okay, can anyone walk us through this?
Negative 3x plus or minus 6 plus 6.
Plus 8, good.
I'm sorry.
So negative 3x is alone by itself, right? In other words, so negative 6 plus 8 will be positive 2. And this is the combined simplified form. Any questions? Any questions? Okay, perfect. Moving on. Feel free to ask questions or stop me anytime, please. I'd like us to look at the next example. Simplify the following expression. So 2, then braces. 2 minus 3, and then bracket. 3x minus 2, parentheses, x plus 2, plus 4x, and close the bracket and close the braces. Okay, let's take a moment and copy this down. It's a mouthful. I don't even know where to start. Of course I do, and of course you do. We've had something similar in the past. So let's take it easy. So 2 braces, open braces, 2 minus 3, open a bracket, 3x minus 2, parentheses, x plus 2, plus 4x, and close the bracket and the parenthesis. Okay. Can anyone refresh our memory on the starting point? Where is the starting point here?
Parentheses.
Yes. Right
The
here.
innermost.
Say
The innermost.
yes. So right here is the starting point. This is number 1. Good. I copy everything one by one as is. I want to go further. I want to remove this. Okay, perfect. So then we have 2. We copy braces. We copy 2. We copy negative 3. We copy the bracket. We cannot change anything. We copy 3x. Can anyone distribute negative 2 to these two terms and tell us what to write? Anybody other than Sarah and Matt and Glenn, please.
2x plus 4.
Thank you. Say it again.
2x plus 4.
We are distributing negative 2 to 2.
Negative 2x plus 4.
We are distributing.
Plus negative 4.
So
negative 2x versus negative 2, 4.
very good. We close the bracket. We close the braces. So we distribute negative 2 to x, and we distribute negative 2 to 2. Perfect. The next step here is we have to fully combine like terms inside braces. That's our second step. So therefore, I copy 2. I copy braces. I copy 2 and negative 3. 3 apples minus 2 apples plus 4 apples. What do I write?
Five X.
Very good. And then minus 4. At this point, I must distribute negative 3 because there is a product here. It's invisible, but it's there. Do not try to attempt 2 minus 3. That would be a terrible mistake. We distribute negative 3 to these two terms because we want to eliminate brackets. Good. So we have 2. We copy 2. Can anyone distribute negative 3 to these two terms?
15X plus 12.
Plus 12. And we close. At this point, I have to eliminate everything, simplify to the bone inside braces. So this will be, this was step number 3. This will be step number 4. I can't touch anything else. I just have to combine like terms. Notice one thing. I always present everything simplified in order, in the descending order. Descending order. This should be our second nature. Now, so I have 2 with braces, negative 15x, and 2 plus 12. Now this is indeed the final step. What is it? There is an invisible product symbol here. So I have to distribute 2 to these two terms. And the final answer has to be presented in descending order. So then we have, can anyone finish this up for us? Matt, Glenn, and Sarah, they are not banned. Sorry, I didn't want you to think that.
Negative 30 plus
Negative 30x plus
20.
negative 30x plus 28. Any questions?
Why couldn't you do 2 minus 3 and then distribute?
By the order of operations. The order of operations will never allow me to subtract before multiplying. That's never allowed.
Okay.
So see, 3 has subtraction on this side and multiplication on this side. I could never touch or subtract 2 minus 3.
Okay, that makes sense.
Because this is a much more powerful operation. I'm not allowed to add and subtract before I multiply or divide from left to right.
Gotcha.
Perfect. Good. Let's see if there is anything else. This is a piece of cake in comparison to what we just did. Okay, so let's look at the perimeter. Okay, so the width of a rectangle is W yards. And the length is 3W minus 8 yards. The perimeter is given by this. 2 times W plus 2 times 3W minus 8. Simplify the algebraic expression, this one, and determine the perimeter of a rectangle whose width W is 6 yards. So let's take 1 minute and work on this problem on our own, please. So this is 2W plus 2 times 3W minus 8. And then they're asking us to calculate the final answer when W is 6. Same thing. Same thing. Okay. Perimeter again. Perimeter again. Perimeter again. And the area. Okay. That's good enough. Good. Do we have an answer for the first part?
Are we supposed to tell you?
Yes, do we have an answer for the first part? Let's just do it step by step.
Okay.
So we have 2w plus,
6W,
yep, minus,
6W,
good. And then you will combine like terms.
8W,
And now I need to, so this is the perimeter, 8w minus 16. And we're asked to calculate, evaluate the perimeter when w is 6. So 48 minus 16 is 32. If this is in feet, the perimeter will be in feet. If the perimeter is in inches, then it will be inches. If it's centimeters, it will be centimeters. Any questions on this before we move on to 1.5? Any questions? Okay. Continuing then. Okay. I did not wait till this moment, we already started solving equations. We did use the addition method, although I didn't tell you what it was. And we used the multiplication method, but I didn't tell you what it was. Because it was just common sense, but it doesn't matter. We're going to work on problems as many as we need. I choose, you choose. So we want to solve equations. Now, the very beginning is exactly what we did after we solved the equation. After we solved an equation, if you remember from the previous lessons, we said, is this true? I have no clue. And we went back and checked. So this is what we start with. The question here is negative 3 a solution of this? Okay, I'm going to copy the problem. 6x minus 7 over 5 equals 3. And they say, check whether negative 3 is a solution. This is a piece of cake. All I have to do is replace x by negative 3, perform the operations I see on the left-hand side. If I do get a true statement like the left-hand side equals the right-hand side, I will say yes. If I do not get, let's say I get negative 3 does not equal 3, then I will say no. Negative 3 is not a solution. So when I plug it in, I have 6 times negative 3, which is negative 18. Negative 18 minus 7 is negative 25. Negative 25 divided by 5 will never be 3. And I will say absolutely not. Let me write what I just said.
Talk to 2.
So, negative 18 minus 7 divided by 5 is negative 25 over 5, which is negative 5. But negative 5 on the left-hand side does not equal 3 on the right-hand side, which means x equals negative 3 is not a solution of the given equation. But I'm here. I want to solve it. So we know negative 3 is not a solution. But can we solve this? Yes. Remember when we have, I don't have an onion to show you, But let's assume I have an onion right here. And imagine that I peel the first layer, the outside thin air of the onion. This is exactly what I need to do now. What is the first layer I have to peel off from this? And the first layer that I have to peel off is the division by 5. This is what I have to peel off. How will I reverse division by 5? Only by multiplying both sides by 5. So this is the outermost operation. So I have to remove the 5 because 5 is in the denominator. In other words, I have a division. I have to use the inverse operation because I am allowed to simplify only factors. So therefore, the left-hand side is 6x minus 7. The right-hand side is 15. So I peeled off the thin layer of the onion. Now I need to peel off the next one. What am I trying to get to? I'm trying to get to x. I'm trying to get to the core. This is what I'm asked to find. The question is x. But I haven't gotten there. I haven't arrived at x yet. I'm peeling off. I'm peeling off the division. Now I have to peel off or remove what?
-7.
Yes. In order to peel off -7, all I have to think of is I'm moving a term from one side to the other. It's negative here. It will be positive there. So 6x equals 15 plus 7, which is 23. Oh, sorry, of course, 24.
22.
My calculate, what am I doing? Good. Absolutely, 22. Okay, I'm already thinking, no excuse. I'm already looking at the next step. Good. So now I got closer to x. Final step. What do I need to peel off? I need to peel off the 6. So I will divide both sides by 6. 6x divided by 6 is finally what I want. 22 divided by 6, remember both are even numbers. I will have to simplify and I get 11/3. Question, does this work? I have no clue. But I know I don't need anybody to tell me whether this is correct or not. I have to go back and put it in the problem. So 6 multiplied by 11/3 minus 7, everything divided by 5. If I get 3, I'll say okay. If I don't get 3, I'll say I messed up again. So first, I need to simplify. Do not multiply if it's possible to simplify first. 6 is in the numerator. 3 is in the denominator. I can divide by 3. It's always easier to simplify than multiply and then worry about big numbers. So I only have 2 times 11. 22 minus 7 over 5. Are you with me so far? Then I subtract. 22 minus 7, yes indeed, is 15. Now I'm ready to simplify or divide. 15 divided by 5 is 3 indeed. And then I'll say yes indeed. This is correct. This was not a trivial problem. We had many steps. Then we had to go back and check to make sure that this is the correct answer. Again, what did we do? We eliminated the denominator first. In order to eliminate the denominator, I have to multiply. Then when that was done, we had to separate the term with a variable from the rest. So we moved -7 to the other side. And we did get 22. Then we had to remove the 6, but the 6 multiplies x. So I have to use the inverse operation, which is division by 6. 6x divided by 6 is just 1x. And then 22 divided by 6 simplified by 2, because they're both even numbers, 11/3. Then was this true? I had no clue. I had to go back. I plugged it in. It turned out that this quantity simplifies to 3. That's all I needed to see. And now I guarantee that this is correct. I don't need anybody to say yes or no.